All right, let's talk about something you've probably used a million times if you've touched JavaScript. Arrays. This seems simple, right? But how do they really work? And what are the common traps that can absolutely tank your code's performance? Well, today we're going to break it all down. So here's the game plan. We'll start with the why. Why do we even need arrays? Then we'll get into the nitty-gritty of creating and accessing them. From there, we'll look at some cool patterns like stacks and queues. And then the fun part. We'll pop the hood, see how they actually work, and talk about performance and some pitfalls you definitely want to avoid. Okay, let's jump right in. Why do we even have arrays in the first place? What's the core problem they're built to solve? Think about it this way. How would you store something like a shopping list, or maybe a line of users waiting to get into a website? The keyword there is ordered. You need a first thing, a second thing, a third thing. Now your first instinct might be to just use a regular JavaScript object, but that's where you start to run into some problems. I mean, look at this. You can totally use an object with keys like 0, 1, 2. It kind of works, but it just feels wrong. It's clumsy. It's not what objects were designed for. Arrays, though, they are purpose-built for this exact scenario. They are designed for ordered collections from the ground up. Okay, so arrays are clearly the way to go for ordered lists. Now let's get into the building blocks. How do we create them and how do we access the stuff inside? So the easiest, most common way you're going to see an array created is just with these square brackets. It's clean, it's simple, and honestly, it's the standard. You just pop your items right in there, separated by commas, and you're good to go. All right, so once you've got your array, how do you get things out? It's all about the index. And remember, the big rule in programming is that we start counting from 0, not 1. So fruits 0 isn't the 0th item, it's the first item, apple. You can also use that same bracket notation to swap something out, like changing plum to pear, or even add a completely new item at the end. And that .length property, super useful. It tells you exactly how many things are in your array at any time. Now here's a classic problem. How do you get the last item in an array? For a long time, we had to do this kind of awkward calculation to get it. But luckily for all of us, JavaScript has evolved, and there's a much nicer way to do this now. And just look at the difference. The old way on the left, yeah, it works, but fruits.length minus 1, it's a mouthful, and you have to stop and think about it. But the new way, fruits.at negative 1. It's just so clean. Using a negative number just means count from the end. So negative 1 is the last item, negative 2 would be the second to last, and so on. It's a game changer for readability. All right, with those basics covered, we can start doing some really cool stuff. Let's talk about a couple of super common patterns you can build with arrays, stacks, and queues. First up, let's talk about a queue. The best way to think about a queue is, well, a queue, like a line at a grocery store. The first person who gets in line is the first person to get checked out. It's a first in, first out system, or FIFO. In array terms, that means we push new people onto the end of the line, and we shift the person at the front of the line out when they're done. Then you've got the opposite, which is a stack. This is last in, first out, or LIFO. The perfect analogy here is a stack of plates. You put a new, clean plate on top of the stack, and when you need one, you take the top plate off. The last plate you put on is the first one you take off. Simple as that. So to make these patterns work, we have 4 main tools. You've got push and pop, which both deal with the end of the array. Push adds to the end, pop removes from the end. That's your stack of plates right there. Then you have unshift and shift, which deal with the beginning of the array. Unshift adds to the front, and shift removes from the front. So if you combine push to add to the end and shift to remove from the beginning, presto, you've got your queue. Okay, this is where things get really interesting. We know how to use arrays, but to become a real pro, you need to understand what's happening under the hood. How does the JavaScript engine actually handle these things? And what's the best way to loop through them? Let's find out. So here's the big secret. At its core, a JavaScript array is actually an object. Yep, but it's a very special kind of object. See, the JavaScript engine knows that we use arrays for ordered lists all the time, so it has a ton of super smart optimizations built in just for them. The catch is, we as developers can accidentally do things that break those optimizations, and that's when things get slow. And here are the 3 big ways people mess this up. First, you add non-numeric properties, like array.test equals 5. Remember, it's an object, so you can do this, but you shouldn't. Second, you create these huge empty spots or holes in the array. And third, you fill it up in some weird order, like backwards. When you do any of these, the engine basically throws its hands up and says, okay, fine, this isn't a real array anymore, and it switches back to a slower, more generic object mode. Not good. And this right here is a perfect example of why that matters. The for of loop is the modern, correct way to loop over array values. It's fast, it's clean, it does exactly what you want. The for in loop, on the other hand, is designed for generic objects. It iterates over all the properties or keys. If you use it on an array, not only might you get unexpected results, but it's also way, way slower. We're talking 10 to 100 times slower. That is a massive difference. All right, let's wrap this up with the stuff that separates the beginners from the pros. We're going to talk about performance and some common pitfalls that can lead to some really nasty, hard to find bugs. Okay, if you remember one thing about array performance, let it be this. Working with the end of the array using push and pop is blazingly fast. It's almost free. But working with the beginning of the array using shift and unshift, it is slow. And the bigger your array gets, the slower it gets. So why is it so slow? Well, think about what has to happen. When you shift, you're removing the very first element at index 0. But now you have a hole at the beginning. To fix that, the engine has to take every single other element in the entire array and move it one spot to the left. Element 1 moves to 0, 2 moves to 1, and so on. If you have an array with 1,000,000 items, that's 1,000,000 operations. It's a huge amount of work. Push and pop don't have this problem because nothing else needs to move. Okay, I guarantee every single person watching this has done this at some point in their career. You have two arrays that look identical. You compare them with double equals, and it tells you they're not equal. And you're left scratching your head wondering what on earth is going on. Here's the trap. As we said before, arrays are objects. So when you use double equals, you're not asking, do these two arrays have the same stuff inside them? You're asking, are these two variables pointing to the exact same object in my computer's memory? And in this case, they're not. They're two separate arrays that just happen to contain the same values. It's like having two identical cans of soda. They have the same contents, but they are physically two different cans. If you want to check if the contents are the same, you have to loop through and compare each item one by one. So let's do a quick recap of the most important points. 1. Arrays are your go-to for ordered collections. 2. For performance, stick with push and pop at the end of the array whenever you can. Avoid shift and unshift on big arrays. 3. When you loop, use for.of, not for.in. And finally, 4. Don't ever use equals equals to compare arrays. You gotta check the contents yourself. So now you have a really solid foundation. You know what arrays are for, how they work under the hood, and the major pitfalls to avoid. But this really just scratches the surface. The next question is, what else can we do? How do we sort these arrays, or search for things inside them, or transform them into completely new arrays? Well, that's where the real power lies, and it's a journey for our next chapter, diving into array methods.